Hello, good evening. Let's wait for a few more to join. Hello. I hope I'm audible and very good evening. We'll just wait for one more minute and then we'll start. So, a very good evening, and I hope all of you are safe, sound, and healthy. Yes, good evening, Gokul. Welcome to my class. I hope you're doing good. Yes, it's time for us to start. So, welcome all of you to Let's Crack CBSE Science. So, prior to our lessons, let me give you a self introduction. Good evening, everyone. Hello, I am Shalini. I'm a BTech and MTech holder in computer science and engineering. I'm a teacher by profession with over 14 years of teaching experience. With Unacademy, I'm excited to provide an inspiring learning experience to all the students via exploring this online platform, whom I could not have reached otherwise through my offline or classroom teaching. So, here, prior to the class, let us have a small tour to the Unacademy and its various provisions. Though it is nothing unfamiliar to any one of you today, Unacademy has grown to be the India's largest e-learning platform. So, it has grown to be the India's largest e-learning platform, not because of the current situation, but also for the reason that it provides um, courses. It is like a one-stop destination for all courses, whether you are a school-going CBSE student or you are an aspirant preparing for a competitive examination. You get all resources for your preparation under an academy. Okay. So here is a detailed description of what you will get in an academy once you get subscribed, or once you take a subscription based on the plans that you would like to. So you get daily live classes wherein you can chat with the educator, engage in discussions, ask your doubts and answer via polls. Now all the facilities while the class is going on. Now, all the courses in an academy are well structured in line with your exam syllabus to help you best prepare for it. Okay. And from the educators all over India. Now, there are also live tests and quizzes which would evaluate your performance and gives you a detailed analysis of your performance. This would give you an indication of how well you're getting prepared for the forthcoming examination. Now, if you miss out a live class, you needn't worry about it because there is recorded versions also available. So once you get a subscription, it would allow you, or it is a gateway opening for unlimited access to all the resources in Unacademy. You get access to the live and recorded courses to watch from the comfort of your device or your time. Okay. So this is how the comprehensive syllabus of an academy will look like. You will have the different subjects listed, and underneath each of the subjects you will have the different courses offered by various educators. So you could go into the so this is how the syllabus of a CBSE school student might look like. So underneath each of the subject you would have the courses, and based on your need you may go refer to the course posted by the different educators. Now, this is the Unacademy learning app. Okay, so you can download and install in your smartphones. Do not forget, it is the Unacademy learning app that you have to download and install in your smartphones and get the subscription based on your choice. Okay. Now, apart from that, you have a Telegram channel also. Now, what the Telegram channel offers is you get access to all the study materials posted by different educators. Now, to get access to this, what you just need to do is download the Telegram app in your smartphones. And then you see the link that is being given here as shown in the figure. What you need to do is just type the link in the URL as shown in the figure and then click to join in the channel, wherein you get access to the materials, study materials posted by the different educators. Okay. So here is a detailed description about the subscription fee details. So CBSE Class 12 subscription fee details. Now below are listed in two tables the different plans, and across each of the plan you have the subscription fee also. So the plan ranges from 1 month to 12 months. Okay, a 1 month subscription costing you around 2,500 to a 12-month subscription or a year subscription that would cost you around 12,500, but you have an attractive offer if you apply my referral or promo code SLYT. If you apply my promo code SLYT, then you get a reduction in 10% of the fees. That is, a course fee of 2,500 would cost you only 2,250. Now the same reduction goes in the plans below also. Okay, so let me just take a break of a minute. So yes, now let's pitch in. So welcome to Let's Crack It. Let's crack CBSE Science. Now, as I told you earlier, we have been dealing with the CBSE Class 12th Computer Science. Yes, hello Devika, good evening and welcome to my class. So, we have been dealing with the CBSE Class 12th Computer Science, and we have been following the topics as mentioned by the NCERT syllabus. And today we're going to learn the introduction to data structures. Okay, so we're going to learn what are data structures, what are the different types of data structures, and in the coming classes or in the forthcoming classes, we'll look into each of the data structure in detail to study stack and queue as per the NCERT syllabus. Okay. So today we'll be just looking into or brushing up the introductory topics as to the definition, the different types, the categorization, and what exactly a difference between data type and data structure means. Okay, so all this we'll be looking into. Yes, good evening, Aina. I hope you're safe, sound, and healthy. Welcome to my class. So, these are the contents that we'll be covering in today's presentation. We'll look into the introduction, the introductory topics. We'll look and see the differences between data types and data structures, and the main categorization, the different types of data structures in Python. Okay, not just in Python, and categorization of data structures. And then we would look into two of the main things that we need to learn. Okay, so prior to going into data structures, we really need to understand what is the actual purpose, or why do we need a concept called as data structures. Okay, now computer, the device, is a data manipulation system. Okay, so what does it do is it takes in data from the external world, process it to make it into meaningful form. Okay, now the data changes into information, and this is how the output is being casted to the external world. Okay, so this is how the electronic device computer works, or in short it is the data manipulation system. Okay, so here what happens is the data are aggregated, summarized in meaningful ways to yield information. So how is the information generated from the raw data? They are aggregated, that means they are summed up, they are collected from all points and then summarized in meaningful ways. To summarize it, some sort of processing takes part on this raw data and facts and figures, so that what is yielded, it yields to give you something called as information. Now, only when the raw data or facts are converted into information. Hello, I hope I'm audible. Yes, dear students, can you hear me? Yes, I think I can hear my voice. Okay, so we just saw what is a computer. Okay, yes, okay, thank you, Devika. I think there was a problem from my end now. Okay. So as we told, discussed what a computer is. Okay. So computer is nothing but a data manipulation system. Now, how does it manipulate the data? The raw facts and figures, which are called as the data, they are collected, aggregated, they are summarized. Okay. And they are summarizing means they are grouped into meaningful form. And hence that grouping is, or the meaningful representation is called as information. Now, in the process of conversion from data to information, now in midway, the system which is holding the data has to represent it. Okay, it must be represented, it must be stored, organized, processed, and managed. Okay, so this is how, or these are the processes that would happen to your data. What all happens here? The data must be represented, so there should be some mechanism to represent this in your system, to store it. Okay, how the way it is stored in the memory, how well organized it is processed and managed to support the user environment. Okay, the effective and reliable way to achieve this is using the data structures. Okay, so the most effective and reliable way to achieve this is using data structures. So I hope now you have an idea why we are learning data structure. So whatever raw facts, prior to processing it into information, it takes the aid of data structure. Now, why does it take the help of data structure? For the data to be represented, stored, organized, processed, and managed to support the user environment. Okay, so hence the use or the explanation of why data structures are needed. Okay, Now let's see the definition for the term data structure. So it is a named group of data. So you have a collection of data, right? And you associate a name for the collection so that whenever you want to access the collection of data, it is just enough to indicate it or refer it using the name. Yes, Ritvik, good evening. Welcome to my class. Okay, so a data structure is a named group of data of different data types. So the next thing that you need to know is the first thing is you have a collection of data. The collection of data is associated with a name, and the data might or may not be of different data types. Okay. The next thing, it is stored in a specific way and can be processed as a single unit. Now it is having more than one data, so definitely there should be some mechanism for storing it, right? So it has to be stored in a specific way and it can be processed as a single unit. Now, though it is a collection of data, it is processed as a single unit. Now, the data structure has well-defined operations, behavior, and properties. Now, what is a data structure process? It has a well-defined operations. Now, these are the set of operations and this is how each operation has to be performed in a data structure. So, every operations with regards to a data structure is well defined. Okay. Now, how does the data stored in a data structure behave? Okay, so that accounts for the behavior and later the properties. Okay, so the properties of the data which are stored inside the data structure. So these are the main things that we need to know or we need to keep in mind when we are learning the concept of data structure. Okay. So as per the definition, we say that there is a name associated with it. Okay. Now, since it's a structure, so that means it is not just holding a single data, but it holds a group of data. Okay. Now, the second thing is it may or may not be of different data types. Okay, so there is no restriction for the data types. Now, when we learned strings, we saw that it is a collection of data, but in that case, we had a restriction that all of the values stored in a string should be mandatorily characters, right? Now, that was the case when we talked about a data type, right? And here we are talking about another thing. What is that? That is the data structure. Okay. So, moving on, let's see the difference between data type and data structure. Now, I told you a difference in the previous slide when we were talking about string. Okay. But string was considered as a data type and not as a data structure. So, to differentiate this, we need to understand what data type indicate and what data structure indicates. Okay. So a data type, it defines the set of values. Okay, it defines the set of values along with the well-defined operations. So there is a category of operations and they are well defined, stating its input and output behavior. Now, if you have a data type, a variable associated with a data type, now this data type will define what is the range of values this particular variable can take. Okay. Now, what are the possible values and as well as the range of values? Now, what are the possible set of operations that can be performed on the data or the set of values? Now these are all behaved with respect to the input and output behavior of the set of values. Okay. We learned that integer is a data type, string is another data type. Okay. List, dictionary, all those are data types. Now let me give you a small example. When you're considering integer, okay, you have numbers. Now in the category of numbers, you can either have integers as well as floating point numbers, right? Now an integer is a category of values which will not have a decimal point, but once it has a decimal point, we call them using floating point representation, right? So integers, floating point, etc. are data types. Okay, so they have a mandatory set of representation. Okay, the rule says how to represent it and what are the set of values accepted, what is the range of maximum possible range of values that can be accommodated as well as the defined operations. Now, let us see what a data structure is. It is a physical implementation that defines a way of storing, accessing, and manipulating the data stored in a data structure. So, data structure is something, it can be imagined as a place wherein you are storing the data in some ordered or in some specific way. Now, in this specific way, there will be restrictions or there will be rules telling you, well-defined statements that would be telling you how to insert a value inside the data structure, how to take a value from the data structure, what kind of operations can be performed on the data structure, okay? How is the data manipulated so that it yields information? Is the idea clear? Now, the category of operations or the category of listing of manipulations done on data structure is entirely different when you compare that with data type. Okay, data types will give you the type of value that can be stored, and data structure is actually a storage or a specific method which helps you to arrange or store data. Is the idea clear? The example, stack. Now, stack is a data structure which we'll be seeing in the coming classes. In a stack, all insertions and deletions. Insertion means adding a value. Deletion means deleting a value. Now, both of these take place at one end only. So, this is a restriction with regards to a stack, which is the well-defined operation when we consider stack. Okay. So, I hope the difference between the data type and data structure is clear to you. So, moving on. So the different data structures. Now this is a figure this figure can easily help you understand what are the different categories, broad classifications of data structure, and if you have some innermost classification, what are they? Okay. So the figure looks like a hierarchical order in which the root has the data structure. Now, this data structures is broadly classified into two. One is called as the simple data structure and the other is called as the compound data structure. Okay. The data structure or the term data structure are broadly classified into two. The first one is a simple data structure and the second one is a compound data structure. Okay. Now, simple data structure means there are no complications in how it is arranged or how to access values from the data structure. An example for a simple data structure are arrays or linear list. Okay, arrays or linear list. Now, the compound data structure. So, compound data structure are again classified into two, which are linear and non-linear. Now, linear meaning, the little meaning says along a line, right? So, linear means the data are arranged along a line. The accessibility is also that way. The traversal also, if you need to travel along, you travel along the line visiting each of the position. Okay. Now, the linear data structure or compound data structure, the examples are stack, queue, and linked list. Now, you have one more classification underneath compound data structure, which is called as the non-linear data structure, and an example for nonlinear data structure is nothing but tree. So I hope this graphical representation is clear to you. It gives you an study about the different data structure. Now the main broad classification are simple and compound data structures are again divided into linear and non-linear. Okay, so let's move on to learn what are simple data structures as well as what are compound data structures. Now, simple data structures, these are normally built from the primitive meaning fundamental, Fundamental data types like integers, reals, characters, boolean, etc. Okay. So these are the data structures that are built from the primitive or fundamental data types. Okay. An example of it is arrays or list. Now we'll be seeing into each of these data types later, data structure later on in the coming slides. Now let us here at the present have only the distinction or in the definition of symbol as well as compound data structure. Okay. Compound data structures, they are simple data structures combined in various forms. So one or more of the simple data structures which are combined in various ways to form more complex structures. Okay, so when the simple data structure combine itself in various ways, what is your end result? Your end results are compound data structure. Now this compound data structure are further classified into linear and non-linear, wherein the linear data structure, as I told you, as the little meaning of the word linear says, it is arranged along a line. So the elements form a sequence, right? Now these data structures are single level data structures. So it is nothing like you have a hierarchy in defining the data structure. You just have a single level and all the data would be arranged in this particular single level. Okay. So example next is nonlinear data structure. So if linear data structure had a single level, what would be nonlinear data structure? It could be definitely multi-level, right? So the examples are stack, queue and list for linear and tree for non-linear data structure. Okay. Now, we are going to see each of these data structures in detail. So, we'll be covering only the definitions today and the detailed study will be coming in the forthcoming classes. So, linear list or arrays. Okay. Now, we'll first look into the definition and then we'll have an understanding of how the linear list or arrays look like. Okay. So the linear list or arrays, it refers to a named list of a finite number n of similar elements. So it is a list of values, okay? So linear list, okay? And then it is having finite number of elements. So the number of elements in the array or a list is countable or finite. The second thing, each of the data elements. So you're having a collection of data and each of the data can be referred to as data element. So each of the data elements can be referenced respectively by a set of consecutive numbers. Now, why is this referencing done? The referencing is done to indicate the position of each of the data element. If the name of the list is L, its elements will be referenced as L of 0, L of 1, etc. Okay. Now let's see what arrays in other programming language would mean. Yes, Priyanshu, good evening. Yes, Abhay, good evening. So let's see what exactly arrays in the other languages would refer to. Now, array can be imagined as a linear box, okay, a rectangle box. Now, in this box, you can have different cells. Now, each of the partition indicates a cell. So, excuse me with the width, I am poor in drawing. Now, inside each of the cell is capable of holding a data, okay. Now, this data is referred to as data elements in the further point of view. So suppose I have the values 10, 20, 30 and 40. Okay. And I have a name associated with this array. Now let the name be array itself. Okay. Now the element 10, 20, 30 and 40 are inside the array, inside each cell of the array. Now you have position numbers or index values associated with each of these values. Say you have 0, 1, 2 and 3. Okay. So these are nothing, what I've written on the top are nothing but the position or the index values. Is the idea clear? The position or the index values, and inside the array you have the values, the actual data elements. Now suppose you have to refer the element 10. How do you do it? The name of your array is ARRAY. Now you can have the position value referenced within square brackets. Okay. Now suppose I'm giving array of 0. What would be there? It indicates the data structure array. Okay. And the position value 0. So the meaning of this representation is the element in the position 0 of your array. Now which is that element? The element is 10. Is the idea clear? Likewise, you can refer every element inside this array. How? Using the name of the array as well as the position or the index value. Is the idea clear? Now the same thing, it happens in Python in the form of list. We had already seen that. How does list appear? Now list also has a name, okay, and the values are enclosed between square brackets separated by comma. The same thing appear like this: 20, 30 and 40. Now L of 0, the representation L of 0 indicates the element at the 0th position of your list L, right? So in Python also we came across the same thing, okay, but with a name list and not as arrays. Okay, in other languages we learn it as arrays, and here we learn it as list. Okay, list is how arrays are implemented in Python. Now, when you're talking about arrays, the next thing that you need to learn is arrays can be of any dimension. That means arrays can be either single dimensional or multi-dimensional. Okay, what is it? The arrays can be either single dimensional or it can be multi-dimensional. Now, single dimensional meaning the same thing that we just described now. It is growing in only one dimension. Okay. Now, when you're talking about a 2D array, the example you can cast is matrix. Now, see here the matrix. If you am talking about a 2 cross 2 matrix, let me guess the elements to be 1, 2, 3, and 4. It is having 4 elements arranged in 2 rows and 2 columns, right? Now, this 2 cross 2 matrix can be an example of a 2D array or two-dimensional array. Now, two-dimensional array is an example for the multi-dimensional array. So, hence the concept of arrays, and in Python you do not have something called as arrays. Instead, you refer it using the name linear list, though both are the same. Okay, so moving on. We're going to see the next data structure. What is the name of the structure? Data structure, the name is stacks. Okay. So it refers to the list stored and accessed in LIFO technique. Now what is LIFO technique? Last in, first out. Okay. So whichever element has entered this data structure very last, it is having the capability of moving out of that data structure in the first priority. Is the idea clear? That is what LIFO means. What does LIFO stands for? Last in, first out. It refers to the list stored and accessed in LIFO. The insertions and deletions take place at one end, called as the top of the stack. Okay. Now imagine that you have blocks. Now you remember the game which you play using the blocks. You tile them up and then you try to remove the block without disturbing it. Now imagine that we are not going to play the same game here. It is something different. Now you have arranged the blocks like this. But suppose you try to remove any of the block, what happens? The pattern gets disturbed and it is very easy to get collapsed. Is the idea clear? You other than this block, whichever block you're trying to remove, what happens? The balance in the pattern gets disturbed and the entire structure is possible to collapse down. Okay. But if you remove the top one, what happens? Do you think the balance is disturbed? No, right? After removing this one, this particular block which I have marked in red, you can remove this or this, both are optional. And then after this second level removal, you can move on to the third level. Okay. Now, what did you see? You saw that they are arranged one on top of the other, and the one that was coming on the topmost was inserted last, right? Now, when you start deleting or removing the elements from the stack, which came out first? Definitely the one that was inserted last came out first, and hence the technique LIFO. Is the idea clear? Last in, first out. So a very simple example that you can imagine is you have piled up or stacked up a pile of plates. Okay. Now, when you go for a buffet or when you go for buffet trying to serve yourself, what do? Do you pick up a plate which is coming at the bottommost? No, right? You start picking up from the top. So this is how the stack works. Okay. But when we were trying to arrange it, you arranged it on one top of the other. But when you're trying to pick up, you always pick up or remove the elements from the top. Okay. Now, hence, this one end of the stack wherein you can insert as well as delete is called as the top of the stack. Okay. So whenever you want to see which is the element on the top of the stack, again you access something called as top. Only then you get to know which element is lying on the top of the stack. Okay, so I hope the definition of stack is also clear. Okay then, so let's move on to our next data structure, Q. Okay, so see the spelling Queuve. Okay, Q. Now Q is yet another data structure. Now we had something called a stack. We explained what was stack. We explained the operations, and then now we're going to learn something called as queue. Okay. Now the queue, it is referred to the list stored in FIFO order. What was stack? Stack followed the LIFO technique, and here Q follows the FIFO technique. Now, what does FIFO? First in, first out. Okay. The first one to enter would be the first one to go out also. You wouldn't keep it waiting. Okay. Now, if this has to happen, that means the both ends should be working, right? You cannot just have insertions and deletions from one end only. No. So in Q, the insertion takes place through one end and the deletions takes place through another end. Okay. Now let's see what are the ends called as. The insertion take place at the rear end and the deletions takes place at the front end of the queue. Now imagine you are waiting at a counter to pay your fees or to get a ticket or something. Now how does you're waiting in the counter in a queue? Now how does a queue progress? Definitely, the ticket would be issued to the person who is very next to the counter or the first person to the counter, right? Now, after issuing ticket to him, he would leave the queue. Now, what happens? So, this is a friend of the queue, and each new person entering the queue would be at the just standing behind the last person. So, this can be called as the rear, right? And the front of the counter, whoever who is facing the front of the counter, he will get his issued ticket and then leave. Now, are they all getting in and leaving from the same point like that of stack? No, right? You have two separate points. One is called as a front and the other is called as the rear. So every time deletions happen through the front, insertions happen through the rear. Okay. So prior to that, so we saw one data structure which is the stack, which follows the LIFO technique. Okay, here insertions and deletions took place at one end, which was called as the top of the stack. Okay, so you were able to insert as well as delete. So actually, this should have been a bi-directional to show that the insertions and deletions can take place only through this end. Okay. Now, one thing that you need to learn when you are learning stack is two terms. One is called as a push and the other is called as the pop. Now, pushing into means you're inserting something. Popping means you're taking out. Okay. So, push operation is the name of the operation associated with the insertion in a stack, and pop is a name associated with the deletion operation in a stack. Okay, so in a stack, the insertion and deletions are referred to using specific names, and the name given for insertion is push and the name given for deletion is pop. Okay. So I hope the stack and queue is clear to you. So let's move on to the next data structure by the name linked list. Okay. So we'll just wait for one more minute. If you have any doubts, you may post in the chat. So I hope we can continue with linked list. Okay. Now let us first see the literal meaning of the word linked list and then go into what the definition says. So, linked list, right? So, you have list of values. Now, each value is linked to the other value. So, this is what linking, or this is what the literal meaning of the data type or data structure indicate. It's not a data type, it is a data structure. So linked list means you have a list of values and each value is linked to the other. Okay. So these are special list of some data elements linked to one another. Now here each element in the data structure is called as node. Okay. So each element in the data structure linked list is called as a node. The speciality is each node has how many parts? Two parts. Okay. Now, what are the parts means? You have to store the value as well as you have to store where the next value is going to reside. Okay. So you have some pointer which is indicating, yes, this is your next value. Okay. So the first part or the info part stores the information and the second part is a pointer which stores the reference to the next element. Okay. Now the list can be either singly linked list or doubly linked list, which we'll be seeing in the next slide. It depends on the traversals. Okay. I hope all of you have played the game Treasure Hunt. Right? How is this game played? You have clues. Okay. So the first thing you yes, Dia, good evening. Hello, welcome to my class. So we were talking about treasure hunt, right? The game treasure hunt. Now, how is this game played? Now, you'd be given the first clue. So you'll assemble at some place, and this place you will have to hunt for a clue. Now, what does the clue tell you? The clue will tell you, the clue has some hint to indicate where you can find the next place or the next clue. Okay, so this is actually linking. So when you go find the clue gives you a indication of the next place. You go to the next place, hunt for another clue. Okay, now this process continues till you end up finding the treasure, right? Now, so how is a treasure hunt game going on? You have a clue, you come up to a place. With the help of the clue, you find out, you reach a place, you find out the next clue. Okay. There'll be clues indicating where the cheat or something would be hidden, and you need to hunt and find out, right? So every time you visit a place, you get a value. This value is a chit. Now the chit has a pointer to the next location or next point where the next chit is being saved, right? So linked list is something similar to your treasure hunt game wherein you have data elements. Now each element is called a node here. Okay. So each location in the treasure hunt is a node here. Now the speciality of the node is it is having two parts. What do it have? The chit has an information as well as a clue to the find out where the next chit is. So similarly, the node has first part as the info part, which is the information or the data value which is being stored. Apart from that, what does it have? It has a pointer or a reference to the next element. Okay. Now, list can be singly linked list or doubly linked list based on the traversal. If you can travel only in one direction, it is a singly linked list. If you can travel in both directions, it is called as a doubly linked list. Okay. So, I hope the idea of linked list is clear to you. So let's move on to a detailed description on linked list. See here, in a simply linked list, I told you each data element is called by the name node, right? So the node would have information as well as what would it have? It would have pointer also. So in simply linked list, the nodes have one reference pointer and this reference pointer is called as next. What does next do? It points to the next node. Okay, pointer is nothing but something which points. So node has a reference pointer to the next node. This happens in the simply linked list because I told you that traversal happens only in one direction. Now let us see how the node would look like. See, the node will look like something like this. It is a rectangle box with two cells. Now in the first cell you would have the information and in the second cell you would have a pointer. Now the pointer is next, which points to the next node. Now this entire thing is called as a node. Now what does a node comprise of? Two parts. What are they? The value as well as the pointer, right? Now to start with the linked list you need some pointer which is called as a start. Okay. Now this should be the pointer that is indicating your first node, the very first node in your linked list. Okay. So the very first node is indicated by the start pointer. Now by traversing through the next pointer of every node, you can travel till the end of your singly linked list. Usually this traversal would go on and the end of the list would be pointed to null. I mean, if the linked list is only going to have three nodes, that means it will have the first node. There will be an indicator to show this is the first node. That indicator is called as start pointer. Then upon traveling through the next, you can traverse and reach through all other nodes. And the last node would be indicated or pointing to null, which would mark the end of your linked list. Okay. So this is what a singly linked list means. Now let us see what a doubly linked list is. I told you in singly linked list you have a traveling or you can travel in only one direction. The reverse direction travel is not possible. In a doubly linked list, the nodes of the doubly linked list have two reference pointers. Now what are they? Other than next, it would have one more pointer which is called as prev or which is pointing the previous. Is the idea clear? So it has prev as well as next. Now what does prev point to? To the previous node and next points to the next node. So by accessing the pointer next, you can travel forward. I mean in one direction, which is your forward direction. By accessing prev or previous, you can access in the reverse direction. Okay. So imagine this is your start and this would be your prev. Okay. Imagine prev is here. So every time now this prev is a pointer from some other node here. Okay. Each node, now this is your node in a doubly linked list. Each node consists of three parts. What are they? It would have two pointers and the information part. Okay. One would be your information or the data element and then the two others would be the pointers. Then it would have two pointers. One is pointing to the previous node and the second pointer points to the next node in the list. Okay, so this is how uh, or these two pointers help you in the traversal easier. See here, priv and next, and then you have bidirectional arrows also to travel. Now to get access to the first node, you definitely need a start pointer. Only then you can travel from node to node. And then you have a priv pointer which would point from the linked list nodes backwards or in the reverse direction. So this is how linked list appears to be. The linked list takes two forms, which are the singly linked list as well as doubly linked list. In singly linked list, what is the restriction? You can travel only in one direction, which is preferably the forward direction. You start with your first node and then progress along each of the nodes in the list till you encounter null. Null indicates the last node. Now, each node in a singly linked list contains of two parts. One is the information part, second is the reference pointer. Now the pointer points to the next node. Now again a node, right? The node would again have an information as well as a pointer part, and this would continue. When you're talking about a doubly linked list, what happens is each node consists of three parts. Okay, each node consists of three parts. The parts are, you have one, the information part, then you have two pointers, priv and next. Priv pointing to the previous node, next pointing to the next node. So since you're having two pointers here, it is permissible to travel in both the directions. Is the idea clear? It is permissible to travel in both the directions in the case of a doubly linked list. So moving on to our next data structure, which is called as trees. Now, in all the above data structures, I mean in the linear data structure, when we learned, we saw that this is just having a single level and everything happened laterally in the same level. But when you're talking about trees, you need to understand it is a multi-level data structure. Okay, what is it? It is having different levels. It is having a hierarchical relationship among its elements. So somebody is in a top level, then you have elements beneath that level, and again so on. So there is a hierarchical structure here. Okay. To imagine the tree data structure, what you need to do is you just need to uproot. You just need to pluck a tree by its root and then put it in the upside down or uproot the tree. Now what happens? Now you have the root on the top and the branch, the stem and the branches below you. I mean below the root, right? The entire shoot system would be pointing down and the root system would be pointing upwards. Now when you have something like this, the topmost point is the root of the tree, and then progressing you have the different branches moving downwards. The same way the data structure is also assigned or aligned. Now here you have the data elements are having multi levels. Okay, the elements follow a hierarchical relationship, and then the elements like in a linked list are also called as nodes here. Okay, and as I told you, what will be the topmost node? The topmost node is the root of the tree. The bottom nodes are nothing but the leaves of the tree. Okay, so the topmost node is the root of the tree and bottom nodes are the leaves of the tree. Now each node has some pointers pointing to the nodes below it. Now, as I told you, when you pluck a tree and then put it in the upside down manner, you see that the entire structure still have connectivity, right? From the root till the leaves or till the fruits, you have connectivity in the plant. Similarly, each node, okay? Now, each node has some pointer which is connecting or pointing to the next node in the same tree. Now the topmost node is called as the tree and the bottommost node, not just the bottom node, but the bottommost nodes are called as the leaves of the tree. In some other programming languages, or we even associate a term which is called as sentinel nodes. These are nothing but the leaf nodes of the tree. Okay. See, this is a figure which would help you understand how the tree would look like. Okay. Now here you have around 7 nodes are there. Now the nodes are indicated by circles and you have the data element or the value inside the node. Now here I have just given A, B, C, D, E, just the alphabets. Now this is simply looking like how you pluck a tree and then put it in the upside down manner, right? Now what will be on the top? The topmost node or the node with A is your root node. Okay, and which are the bottommost nodes? D, E, F, G, right? So these are called as the leaf nodes. So this is how a tree is analyzed. Now here in your class 12, as per the NCERT syllabus, what you just need to know is about the definitions of the various data structures, but you need to know in detail the different operations, the definitions, as well as the applications for stack and queue, which we'll be learning in the coming classes. Okay. So actually with this we have come to the end of all the data structures. Now prior to winding up, we need to learn one more thing which is called as all the permissible operations in data structure. Now at this point, what are the operations that we know? We know how to add an element. Definitely an element can be added in a data structure. Now elements in the data structure can be deleted. And suppose you need to find out whether a particular element is present inside the data structure or not. That particular operation is called as searching. Then you can travel through the entire data structure, which is called as traversal. You can arrange in some specific order, which is called as sorting. And if you want, you can join two or similar data structure to form a new data structure. I'm sorry, to form a data structure. Okay, tree. And yes, in data structures for assigning values, and even in the real world applications also, we use the same data structure. Say for example, some sites in which you can have values and then values associated with it. See, if you want to have, imagine the hierarchy in your school. Okay, the hierarchy in your school, you have the principal, then you would have the different administrative heads. Okay, then below that you would have the teachers, and then below that you would have the students. Okay, now this is the hierarchy in your school environment. So we are now currently talking about only the principal, the administrative authorities, the teachers, and the students. Okay, so now you have 4 levels. Now you're trying to write a program for implementing this. Now you can arrange all these data elements in the form of a tree. Okay. Now, since this is a hierarchy that you're going to follow, the root node or the principal would be given the ultimate authority. And from the principal, you can reach to any of the student in your school, right? Any of the student in the sense, you can have the admission number. From the admission number or from the office, you can have a link to which particular class the student is residing in, and from the class you can contact the class teacher, and then from the by or via the class teacher you can access the particular student. Now each class would be having a separate class advisor or a teacher. Now similarly you would have separate different nodes associated like this. Okay, principal, office, then you have teachers, and then underneath each teacher you can list each class. So something, I mean a similar structure like this is implementing trees. Okay, in Facebook also for certain things you use the data structure tree. Okay, so moving on to the different operations on data structure, as I told you, we saw insertion, deletion, searching, traversal, sorting, and merging. Okay. Inserting means you are adding a new element in a data structure. Deletion means removing the data element from a data structure. And searching means you have a specified data element. You travel the entire data structure to find whether this particular element is present or not. So this is a process of searching. We'll be looking and learning into the different searching techniques later on in the coming classes. So I'll just name the different searching techniques that you need to know. One is called as the linear search, and the other is called as the binary search. Okay, so these are the main two searching techniques that you need to learn with respect to searching. Traversal we had already seen when we were doing the study of data types too. The same thing can be carried over. Yes, not only in linear list, but almost in all data structures, all these are possible. Okay, it is not just see the heading. These are the operations on data structures and not on a specific data structure. Since the heading is broadly given, this has to be applicable everywhere too. Okay. Yes, Vishwa. And then traversing means you're visiting each of the elements, right? So when you're visiting, you'll be processing all of the elements of a data structure, maybe from the start point till the end of your data structure. Sorting means you are arranging the data elements in specified order. Now it can be either increasing or decreasing order. Now we had already learned two sorting techniques, which were they? Bubble sort and insertion sort, which were mandatory in your syllabus. Apart from that, you have umpteen number of sorting techniques based on the efficiency, as well as, I mean, the speed, and as well as the storage, which we had a separate section in which we learned the different sorting techniques, and then an introduction to what is sorting also, right? Now what is merging? Merging means nothing but combining, right? So the combining um, so combining elements of two similar data structure. Now merging, you need to keep in mind, you can combine only data structures which are similar. Okay, combining two similar data structures to form a new data structure. This is what you call as merging. Okay, so these are the main operations that can be performed on a data structure, as which was suggested not only in linear list, you can perform in any of the data structures also. So, as I told you, when you're learning, searching would be a separate topic that I would deal with it later. Okay, so we'll have to learn the different searching also. That we'll have a separate session in which it will be learned. And with these operations, I mean, with this, we have come to the end of the session. So, Vishwa, you there? I'm hoping that you are there. In the last class, I had already cited a few examples in which the function wherein you could parse dictionaries, lists, etc. We were talking about the different function call mechanisms like call by value and call by reference, in which we already taught that. So I think you missed that session. So you may please go and refer it, wherein the question that you have asked, I have included that too. Okay. So there was a very sample program, very simple program in which I illustrated how you could parse a dictionary and how the processing could be done. Okay, just the previous lecture prior to this. Okay, so with this, we are summing up today's session. So we have come to the end of today's topic. I'm sorry. So to summarize, today we saw an introduction to data structure. Then we saw the difference between data types and data structures, and also the different types of data structure. Just a minute. I think my throat is going bad. I'm sorry. Okay. So with this, we have come to the end of today's lessons. So I wish all of you have a good night. Wishing all of you a very good night. And before binding up my session, let me remind you of my promo code SLYT, which would help you in getting a discount of 10% in the Unacademy subscription. Okay. And the details of the Telegram channel as I have listed. So I hope there are no more doubts. So shall I wind up? So bidding good night from Let's Crack CBSE Science. Is there anything you want to ask me specifically? You may please post in the chat. So I hope there is nothing. Thank you all for joining. I hope to see you in my next class too. So today is Friday, so we'll be having a session tomorrow at the same time in YouTube. And we'll be having a morning session as usual in the Unacademy app too. Okay, so with this, I'm winding up today's session. Good night and see you all tomorrow. Thank you.